Unit 6, Parallelograms, by Julia, Noah, and Ryan. Objectives. During this paper slide video, you will be able to identify different types of parallelograms, determine angle measurements with parallel lines and a transversal, identify relationships between angles, and identify trapezoids. One type of angle relationship is called an alternate interior angles. You know that they're alternate and interior because they're interior to the parallel lines and alternate across the transversal. Therefore, angle 1 is congruent to angle 2. Another type of angle relationship is an alternate exterior angle. It is exterior to the parallel lines and alternate across the transversal. Therefore, angle 1 is congruent to angle 2. There's also corresponding angles. They're on the same side of the parallel lines and on the same side of the transversal. Therefore, angle 1 is congruent to angle 2. Same side interior angles, however, are supplementary angles. They are on the interior sides of the parallel lines and the same side of the transversal. If they are supplementary, meaning that angle 1 plus angle 2 is equal to 180 degrees. Vertical angles are across from each other. It doesn't necessarily have to be parallel lines, but if they are across from each other with two of the same lines, then angle 1 is congruent to angle 2. A linear pair are across from each other, across from a line, and they are supplementary angles. Therefore, angle 1 plus angle 2 is 180 degrees.
In order to be considered a parallelogram, a shape must have 6 of these properties. There must be 2 sets of parallel sides, 2 sets of congruent sides, and the opposite angles must be congruent. The consecutive angles are supplementary, so they add up to 180 degrees, and that diagonals bisect each other, and diagonals form 2 congruent triangles. The first type of parallelogram is a rhombus. A rhombus has 4 congruent sides, as you can see here. Rhombi have diagonals that bisect angles, as you can see here, and diagonals are perpendicular. So this and these are perpendicular. And the fourth property of a rhombus is that it possesses all properties of a parallelogram. A rectangle has 4 right angles, as you can see with these squares drawn here. So all the angles of a rectangle add up to 360 degrees. The diagonals are congruent, and they also possess all properties of a parallelogram. A square has all properties of a parallelogram, rectangles, and a rhombi, so it's basically a big mix of everything. It is a parallelogram if it has 2 sets of opposite congruent sides, 2 sets of opposite parallel sides, and if it has diagonals that bisect each other, and if 1 set of opposite sides are congruent and parallel. You can see these properties here. A trapezoid has 2 parallel lines, and the base, it has 2 bases. In order to identify a trapezoid's median, so the middle line, you add base 1 to base 2 and divide that by 2. So pretend if this was 5 and this was 10, you'd get 15 and then divide that by 2, and you get 7.5 for the median. So the median connects the midpoint of one leg to the other, so the median is half of the sum of the bases. To identify trapezoids. Isosceles trapezoids are trapezoids that have legs of equal length and 2 parallel bases. So the definition of an isosceles trapezoid is a trapezoid with congruent legs. It has 1 set of parallel sides, a base that has angles that are congruent, the legs are congruent, and the diagonals are congruent. There's also opposite angles that are supplementary, and the diagonals do not bisect each other. So these do not bisect each other equally.
Example 1. We're given that line A is parallel to line B. We're also given that angle 1 is equal to 50 degrees. The question is, how big is angle 6? So if we start with angle 1 and we know the measurement, we know that angle 1 is 50 degrees and it is supplementary to angle 2. We know this because they are a linear pair. So what we do is we take 180 degrees and we subtract it by 50 degrees to get angle 2. Therefore, angle 2 is equal to 130 degrees. Then we also know that angle 2 and angle 6 are corresponding angles, which means that angle 2 and angle 6 are congruent. Therefore, we know that angle 6 is equal to 130 degrees. Example 2. We're given this trapezoid. We're also given that AB is a mid-segment, which means that both of these sides are congruent to one another. We also know that the mid-segment is half of the sum of the bases. So 2AB is equal to base 1 plus base 2. So what we do is we multiply the length of AB, which is 15, times 2, and then we make that equal to the sum of the bases. Overall, we get 30 equals 5x plus 5. Then, when you solve it out algebraically, you end up getting x equals 5. Example 3. Is ABCD a parallelogram? We are given the 4 points of this quadrilateral, and we're trying to prove if it is a parallelogram or not. So what I chose to do is to prove that one set of parallel lines has the same slope and the same distance, because that proves it is a parallelogram. First, to find the slope, I use the slope formula, which is y2 minus y1 over x2 minus x1. Overall, when you solved it out, I did get the same slope, meaning that AB is parallel to CD. Then, I decided to use distance formula to prove that the sides AB and DC are congruent. I used the distance formula, which is the square root of y2 minus y1 squared plus x2 minus x1 squared. Overall, when I solved for the distances of AB and DC, I found that they have the same length, which is the square root of 10. Therefore, CD is congruent to AB. And since this one set of sides is both parallel and congruent, you can prove that ABCD is a parallelogram. Example 4. We are given this shape. We are also given that these two angles are both 30 degrees, that these diagonals, when they intersect, form a 90-degree angle, also that all 4 of these sides are congruent. Since we are given that the diagonals bisect the angles, because they're both 30 degrees, also that all the 4 of the sides are congruent, given here, and that the diagonals form a 90-degree angle, meaning they're perpendicular. Using all of these 3 things, we can conclude that this shape is a rhombus. Example 5. If AB and CD are parallel to one another, and AD is equal to BC, what is the value of x? Since we know that there's one set of parallel lines, and the legs are congruent, we can conclude that this shape is an isosceles trapezoid. Since we know it's an isosceles trapezoid, we also know that the base angles have to be congruent. Since we are given that angle D is 30 degrees, we also know that angle C must be 30 degrees. Therefore, x is equal to 30 degrees. What did we learn? Overall, we learned the different types of parallelograms, such as a rhombus, a square, a rectangle, and then just a normal parallelogram. We also learned angles and their measurements with parallel lines and a transversal, such as alternate interior angles, corresponding angles, and vertical angles. Also, we learned trapezoids and their characteristics,